Students, in last class we discussed about the filters. So in that we are having capacitive filters and inductive filters. These capacitive filters and inductive filters are used to eliminate or reduce the AC components in the output of rectifier circuit. So in previous we discussed about the capacitive filter with the off-wire rectifier. So this capacitive filter is used to remove the or eliminate the ripples in the pulsating DC. Yes. Now I am connecting this capacitive filter to the full wave rectifier, so we can use that maybe center full wave rectifier or bridge full wave rectifier. So here I am connecting center full wave rectifier with capacitive filter. So you can observe here the output of the center full wave rectifier is connected to the capacitor. It is acting as a filter. So this capacitor is connected to the parallel to the load resistor. Yes. So we are taking the output across the load resistor RL. Yes. For the positive cycle, we know the diode D1 is forward bias. For the negative cycle, diode D2 is forward bias. Yes. So you can observe the output waveform of the full wave rectifier. Yes. So during the time period of 0 to T1, so first positive cycle is nothing but 0 to 5. The maximum peak voltage is nothing but 5 by 2. Here it is represented with the T1. So 0 to T1 time period, what happens? A diode D1 is forward bias, so it is short circuited. In this time period, diode D2 is reverse bias, we know. Yes. So my capacitor will start the charging through the diode D1. So when the diode D1 is in forward bias, capacitor charges through the diode D1 up to maximum voltage, it is Vm. If I am assuming my diode is ideal. Yes. After charging to the maximum voltage Vm, then what happens? My capacitor must discharge. Yes. So during the time period of T1 to T2, what happens? My capacitor starts the discharging through the load resistor. Yes. So during the time period of T1 to T2, capacitor discharges slowly through the load resistor by an amount of VR voltage. That means Vm minus VR voltage. So it decreases up to Vm minus VR voltage. So here we are designing the time constant. The discharging time constant is very high, RL into C. If I am considering only small time constant, what happens? My capacitor will discharge very speed. Yes. So my capacitor will discharge up to 0. Yes. So we are increasing the time constant or discharging time constant, so it will decrease up to Vm minus Vr of voltage. Then after T2 to T3 time period, what happens? It is negative half cycle. So during the negative half cycle, diode D1 is reverse bias and diode D2 is forward bias, so it is short circuited. So now the capacitor is starts the charging. Yes. So now it starts the charging through the diode D2 up to again Vm value. Again after charging to the Vm value, that means it must discharge. So during the time period of T3 to T4, what happens? Again capacitor discharge slowly through the RL resistor. Yes, up to Vm minus Vr value. So it is continuously charging and discharging. It is continuously charging through the diode D1, discharging through the load. Again next it's charging through the diode D2 and discharging through the RL. During the positive cycle, capacitor charges through the diode D1, discharges through the load resistor RL. During the negative half cycle, capacitor charges through the diode D2 and discharges through the RL. So it repeats the same process. Yes. So during the half of the time period, the capacitor starts and discharges. So it performs the two operations, that are charging and discharging in the T0 by 2 of time period. capacitor charges and discharging once in a off time period. So it is equals to T naught by 2 equals to, we can write sum of charging time and discharging time. So here discharging time is high compared to the charging time. So we can say, we can write T naught by 2 equals to T discharge. Yes. So peak to peak ripple voltage we have to written as, during the discharge interval, charge lost by capacitor is equals to the charge supplied to the RL. So it is similar to the offer rectifier. It is equals to C into delta V equals to IDC into T discharge. So by writing the delta V equals to VR, we can write C into VR is equals to IDC into T naught by 2. Why? Because this discharge time is T naught by 2. So we can write IDC VR equals to IDC into T naught by 2C. So T naught equals to 1 by F naught, and then it becomes IDC by 2F naught into C. This is the ripple voltage. In the off air rectifier, IDC by F naught into C. Here we are equals to IDC by 2F naught into C. It is off of the off air rectifier. It is written as RMS value of ripple voltage to the VDC. So here peak ripple voltage equals to VR by 2. So the output of the capacitor is always looking like a sawtooth waveform or triangular waveform. So it is approximately triangular waveform. To analyze easily, we are considering this one as a triangular waveform. So we know the we know the RMS value of the triangular waveform. It is equals to peak ripple voltage by root 3. It is already indicated. It is already mentioned in the during rectifier only. Yes. So now it is V dash RMS equals to peak ripple by root 3, but peak ripple equals to VR by 2. Now it becomes equals to V dash RMS equals to VR by 2 root 3. So VR equals to IDC by 2 F naught into C. By substituting, you will get IDC by 4 root 3 F naught into C. Now from that we can write IDC equals to VDC by RL. So VDC by 4 root 3 F naught into C into RL. So from that ripple factor can be written as 1 by 4 root 3 F naught into C into RL. So we can say the ripple factor is inversely proportional to the capacitor and load resistor. So to reduce the ripple factor, the capacitor must large value and RL is also large value. Yes. So this DC output voltage, it is similar to the previous offer rectifier only. VDC equals to VM minus VR by 2, but here VR equals to IDC by 2 F naught C. So VDC equals to VM minus IDC by 2 F naught into C. Clear? And identify the some of the important points. So in this capacitor filter is connected parallel to the load resistor. So it is always charging through the diode and discharging through the load resistor. If I am disconnecting, if I am removing the load resistor, what happens? How my capacitor will discharge? There is no path to discharge. So then my capacitor will not discharge. So the output, the voltage drop across the capacitor is always Vm only. So hence output is always Vm. So when there is no load resistor, there is no path to discharge. So Vc equals to Vm. So V0 is always equals to Vm. Yes. So and peak inverse voltage is remains same with capacitor or without capacitor in the rectifiers. Yes. So peak inverse voltage will not affected by the capacitor. Next, in a center tap rectifier or bridge rectifier, if one diode is damaged, effective circuit or remaining circuit behave as a off rectifier. So in center tap rectifier, we are having the two rates. So one is D1, D2. So for the first off cycle, diode D1 is conduction and diode D2 in open circuited. For the neutral off cycle, diode D1 is open circuited, diode D2 is in forward bias or in conduction. Yes, if any one of the fails, that circuit will act as only off a rectifier. Similarly, in bridge rectifier also we are having the 4. So for positive off cycle, two diodes will conduct, remaining two are in reverse bias. For the negative cycle, the the left or remaining two are conduction. The first two are in reverse bias. So if any one of the fails, again the remaining circuit will act as off a rectifier only. Yes. In full wave rectifier, if capacitor is used as a filter, then what happens? Diode should have greater current rating. Why? Due to the surge current. What is the surge current? Surge current is nothing but when the diode is in forward bias, the capacitor charges through the diode. So during the charge of capacitor, capacitor draws the large current through the diode. That current is called surge current. Yes, during the capacitor charging period, it draws the large current. That current is called surge current. Due to the higher current, the diode may damage. That's why the diode must supports the higher current. So the diode should have greater current rating. Yes, voltage rating of diode will remain same with capacitor or without capacitor. Why? Because when we are using the capacitor as a filter, the peak inverse voltage of the circuit will not change. So in standard type rectifier, peak inverse voltage equals to 2Vm. In bridge rectifier, peak inverse voltage equals to Vm. So it will not affect the peak inverse voltage. Capacitor will not affect the peak inverse voltage. So due to that, the voltage rating of diode will not affect due to the capacitor. Yes, but the diode current rating must be higher because of surge current. The surge current is very higher, very high value. When capacitor is used as a filter, surge current is greater in the off-wave rectifier. Clear? Surge current begins, capacitor will draw the large charging current through the diode. This current is called surge current. Such huge surge current can destroy the diodes. To avoid the damage of diodes, we must prefer higher rating diode, higher current rating diodes. Clear? Otherwise, we can use this series resistance to limit the current. Clear? And why capacitors is not suitable for the variable loads? So we said we are having the filter elements are either capacitor or inductor. So if there is any drawbacks in the capacitor, then only we'll move into the inductor. Yes. So here we know the when we are using the capacitor as a filter, the ripple factor is directly ripple factor is inversely proportional to the load resistor and capacitor. Yes. So when you are increasing the load resistor, what happens? Ripple factor is decreases. So we know as the load resistance increases, the load current increases. When load resistor decreases, what happens? Load current increases for the constant output, but ripple increases. So load resistor decreases, ripple increases. Hence, filter is not suitable for the variable loads. Yes, the desirable feature of the filter is high voltage and less ripple at the output for the small currents. But when load changes or when high voltage, when load resistance, then what happens? The ripple factor increases. So as a designer, we are always prefer the low ripple factor, but here the ripple factor increases. Yes. So due to this reason, the capacitor is not suitable for the variable loads. This capacitor is suitable for only small loads only. Yes. Thank you.